Hey everyone, welcome back. This is Vivek Bharata. This is the fourth video in Microservices Masterclass course. If you are new to here, I would highly recommend you to watch from the beginning of the course, as I would skip the few of the topics if I covered already in the previous videos. In the last video, we covered almost 75% of the auth service. However, there are some minor tweaks required, like index router has root and health check endpoints, which are actually going through auth and which is basically blocking. So we need to make that as a public routes. That I will cover in the later part of this video, but just as an FYI. And I'll be pushing this fix in the fourth branch of the repository, not in the third branch, just to maintain consistency. In this video, we'll develop account service and also see how we can integrate Kafka for any events, and also we'll be using auth in the account service also. So basically, in the previous video in auth service, we are validating the token and also checking whether the key exists in Redis. So we'll go with the exact same approach for account service also. Then later in the next video, most probably, we'll move this auth checks directly into the API gateway, so that these two services or any of the services not required to check the JWT token, because that validation can happen in the API gateway itself. And also on top of it, if we need an extra layer of security, then we can add the necessary auth checks in respective services. That also will cover down the line, but for now that's the gist of it. And also in the previous video, I actually walked you through from the scratch to develop the auth service. Moving forward, as most of the concepts will be similar, like type ORM, entity definitions, or any of the common concepts which will be applied across the microservices, I'm going to basically walk you through the files and explain if I faced any errors during the development. So that's how we're going to develop the other services in this series. But again, if there are some new concepts which we never touched in the previous videos, of course I'm going to explain those concepts in detail whenever it needed. So this is the rough architecture at this stage, and this notation is basically that we will be building more services down the line. As a revision, I'll just go through this architecture. So the client request comes to API gateway reroutes the request based on the endpoint definition to auth service, account service, or any of the services, and each service respectively connects to Kafka and Redis instances for their business requirements. That's it. Now let's jump back to the code. We'll start with the auth service. Reason, there is one small minor issue where health check also is part of the auth validation. Like for any health endpoint like /health, that endpoint also goes to the auth validation. Of course, the health check really don't need any auth validation, right? So in the previous video in auth service middleware, we defined an auth middleware, right? So we have this public routes. You would notice that in 03 auth service branch, when I release that branch to the public, you won't see these two endpoints in the public routes definition, that is root and the health check endpoint. We missed this in the previous video, and when I was doing some regression, I noticed that these were not part of the public routes, and even to trigger this health, we need a proper token, which is not really required, right? So for the verified token inside, if you see the public routes, if any of the request path includes this public routes, we'll just skip the validation. That's it. So this is like a limited set, and we always make sure that these are actually for the public routes, not for any private routes. Okay. So this is the one small tweak will be fixed in this video's branch. That would be 04 account service. Alright, before moving on to the account service, I'll walk you through two more files which are kind of important. The first one is launch.json file. So here I defined these three services, which is basically a start script. So for the API gateway, this is the name. So workspace folder /API gateway launch run start. Okay. And the similar part we have for auth service and for the account service. So with this configuration, you can basically debug any of the services at this stage. So we have API gateway, auth service, and account service. Down the line, we would be getting notification service, transaction service, and so on. Next other important file is init.sh. Currently, this shell script takes care of creating any topics required for our whole microservices in the Kafka. Technically, as of now, this specific shell script responsibility is to create any required topics for our entire microservices. As of now, we'll be using three topics: user.registered, this we covered in the auth service, account.created, and account.deleted. This will cover in this video, which is for account service. So total at this stage, we need three topics, right? I'm just trying to iterate over here. For topic in topics, you really don't need bash scripting knowledge and all, but I'll just give you a walkthrough of it. So this is an array. We have three topics at this stage, and on iteration, I'm just calling this create topic if not exists this as a variable. That's it. Okay, this will try to connect to the local docker instance, and if you notice here, this is the exact command that will be running inside the Docker container. If you want to know more about Kafka, I have a bunch of videos about Kafka 0 to Hero series. I would highly recommend to watch those later. Alright, so this specific command is responsible to create topics. If you see here, Kafka topics.sh, then bootstrap a server, and this is where we are passing topic name. Partitions and replication factor are the variables we defined at the top. So over here, replication factor is 1, number of partitions 10. So overall, for these 3 topics, we'll be creating 10 partitions with a replication factor of 1. That's all the specific init.sh is doing right now. Later, we might add Docker build commands or any of the commands. We'll see. And at the end, I'm just printing all the topics again, just as a verification. That's it. I'll run this one. And for the new viewers, this is a docker compose.yaml file. We'll be using Postgres definition over here, Redis, Kafka, and Kafka UI. Okay, and for Redis, I'm using Redis stack, so we'll get both the actual Redis server and also the UI part of it, where we can manage and view the whole Redis data. Simple. Okay, let's start Docker containers and run init.sh. Okay, all services are started, and I'll just show you in the Docker desktop Kafka UI, Postgres, Kafka, and Redis, and the respective exposed ports. That's it. Okay, and I'll just open the UI part of it, localhost 8080. So this is the Kafka UI, where we can see the only one broker and the topics, and this user register topic is part of the auth service, which I covered in the previous video. Alright, and if you can remember, we need 2 more topics, account created and account deleted. So let's run this init.sh and see whether those topics are created. And I can just run with /init.sh. Okay, if you see here, connecting to Kafka, container Kafka, checking if topic user registered existed. So when we try to create, we can see that if the topic is already there, we get this error, topic already exists. So that's how I'm just trying to log it and see. And if you see here, creating topic, account.creator, you could ignore the warning for now. Created topic, account.creator. Okay, and the same for account.deleted and user registered. And at the end, I'm just listing all topics in Kafka, account created, account deleted, and user.registered. That's it. Okay, and now let's verify from the Kafka UI as well. And as you can see here, I think user registered partition is only one that we can ignore for now. We can just delete and try to do it. That's okay. That's fine. Anyway, we're going to reset this once we scale up. So that's okay for now. So as you can see, 2 other topics got created with partitions 10. That's it. Okay. And I'll just close this terminal for now, and this compose.yaml file as well. And now let's start with the actual focus of this video, that is account service. So in the account service, this .ini.example, this will be more or less similar to the auth service, but I'll just give a very rough walkthrough for the new viewers. We have this database URL, Redis URL, and Kafka broker, 3 external services what this account service will rely on, and this JWT secret. If you see here, this will be exactly same in the auth service, because auth service is the one which generates the token, and all the microservices will use the same JWT secret and also verify on the Redis for the logout validations. That's it. I can quickly open auth service.env over here. If you see, this is the same value. Auth service, account service. And personally, when I debug anything on live or anything which is very crucial, I always make sure to just copy and search in the other file, so that exactly I'll see whether that string is exactly same or not. Yes, we can trust on our eyes, but when you're validating which is really important, like JWT secrets, I always trust editors, so that it will be more concrete to trust. Alright, now that we covered the environment variables, I'll just walk you through the Bruno setup, which is an alternative to Postman. I just created some folders, and also it's easy to check. And in the root, we have this API gateway health check, and this is similar to the Postman. We have this environment variable, API gateway base URL, and when I hover, you can see localhost 3000, okay, and /health. So we'll be using the similar structure for the other services also. So right now, let's say for the auth, we have this health, auth register, login, logout, okay, and for the account, health, list. So these are the endpoints I created for the account service, which I'll walk you through. And this is how the structure I defined in the Bruno, okay. And also, if I just open the environment variables, so API gateway base URL, token service base URL, account service base URL. So 3000, 3001 for the auth service, 3002 for the account service, and this token and all is automatically being set. How exactly? If you ask how, on the login response, similar to the Postman, we have this post response script. So whenever I get the response from the body, I'm just pulling the token, and I'm just setting here set env var. So Bruno dot set env var. This is the key, this is the value. Simple. And you can just simply access this value with the token key. If you see here, for let's say list, on the auth, I'm just passing the bearer auth as token, and if I hover, you can see the value. Simple. Okay. Alright, let's start with the account service app.ts. So this is the entry point, right? And in the beginning, I'm just getting the env variables, and we have a set of middlewares over here. Request logger, Express.js, you know, the default one, and the important middleware over here, verify token, which validates the JWT token. That's it. Okay, and we have this index router and account router that I'm gonna cover soon. And this app data source is nothing but the type ORM based data source object, and what exactly it's doing. I covered some details in the previous video, but I'll just walk you through at the very high level. So this data source object is basically a type ORM connection object where we'll pass the type of the database, URL, synchronized to is nothing but whether to make the any entity changes in sync with the database if possible, and if it's not possible it will basically throw in an error. That's it. Okay, and logging is false, and entities. So this is where you pass all the entities that you want to define. So if you see here for the entities, I just have accounts over here, but when you compare to the auth service in the data source.ts, we have user and credential. So for the account service right now, I'm just having one table, that is account. And coming to this URL instance, you might question me that, hey Vivek, as you're working in microservices, why do you need the same database URL or the same database instance for across microservices, which is a bad practice in microservices? You would say that is also correct. Again, so for the microservices, in most of the cases, each business domain entity will split into each different microservice instance. Each microservice instance will have its own database. And even in our case also, each microservice will have its own database. Just that as I'm building everything in my local setup, instead of this database URL, you could basically point it to some other instance of the database URL. So let's say in account service, in .env, if you see the database URL is admin, can't remember, this is basically username, password, and localhost 5432, and I'm passing the database name as vbank, right? So what we can do for each microservice, we can have a separate database name itself. Right here in the case of account service, we can have vbank-account service. And for the auth service, right, if you see here in the auth service, in this case it will be same, but what I'm trying to explain is, so over here also it is same, but when you actually deploy to live instances, usually you will end up having a different Postgres instance. But for local development setup, I just use the same database instance. We can actually create separate databases. If you really want that different segregation, I can do that. Let me know in the comments. That's fine, but just that the load might increase in my system, but I'll try. But also for a very small session in the later videos, I can temporarily change this to different instance, and I'll prove you that okay, the microservices are separate and also the databases instances are also separate, or at least the databases names itself are separate. Just that to make it a bit convenient in my local dev setup only, I'm just using the same database name. So let me know in the comments if you really want to just to see how exactly it will be when I just choose the different database name. Okay, alright, moving back to the definition over here. So in the app.ts, so we have this app data source, which is a type ORM's database connection instance, and we are just calling initialize. So only once it is successful, then I'm calling this init. I'm going to explain this in a while, and then later we are actually starting the server app.listen, the config.port, and I'm just printing the services running log. That's it. Okay, and if there is an error, I'm just logging over here. That's pretty much it. Okay, and then later we have this error handler middleware. This is not really required because we already defined that middleware, so I'm just going to use it over here. App.use error handler. I'm going to cover the middlewares in a while, but yeah, we can just use it over here. Okay, and then moving back to this init line, this is nothing but connecting to the Kafka instance as provider. That's it. So if you see here, I just opened this one, index.ts. This is part of the init folder over here. Let me just close auth service. So account service, init, index.ts. Okay, this is the one. So connect Kafka. If you see here, this connect Kafka is again coming from the events folder kafka.ts. So this file is exactly same as the one what we covered in the previous video in the auth service. But yeah, so this is where basically trying to connect. That's it. Okay, I'll come to the producers part later, and I believe till this part it's clear and we covered the app.ts, and looks like this Zod is not required anymore. That's it. Okay, alright, now let's look at the entity definition, like basically the account table definition. If you see here, if I just scroll down, so this is how exactly we're going to define the account table definition in type ORM way. Okay, so for the second class, we have this entity decorator, and then we have all the fields over here. So ID, number, primary generated column, and then user ID. If you notice, this is not like a foreign key we are defining to the user table in the auth service. That's not how it works in the microservices, right? So we're going to just define this as a number and user ID. That's it. And then later we have this account number. Though this is an account number field, but I want to save this as a string with a set of characters that I will explain when we cover account creation request. But overall, for now, you can treat that this account number is basically a string which has a length of 15 characters and all digits. And comment also clearly mentioned numeric account identifier stored as a string. That's it. And then later I just define account name as basically a nickname for that specific customer's account. So either it's a savings or a current for them if they want to have their any nicknames defined in their app, basically. Yeah. And then later we have this account type, and if you see the definition, savings and current for now. For now, only these two, just to make it simple. Later we can have loan account types and so on. And the next field is account status. And if you see, this is also an enum where we have as active, frozen and closed, self-explanatory. Right, and then I have the balance, and if you see, this is basically the decimal notation stating that I can save only up to like 99.19, not like 3-4 decimals, but capped to only 2 decimals. That's it. Okay, so this is the balance, which is basically the main key field which will be actively used in the distributed transactions that I'll cover in the later part of the series. And then we have this currency, created it, updated and closed it. That's it. Okay, so this is very basic account table definition. Alright, now let's move to the middlewares. I'll just give a very quick walkthrough. Auth middleware, this will be more or less similar to the auth service definition, verify token. So I'll just give a walkthrough. So public routes, in this case, we don't have this login and register as compared to the auth service. So root and /health where can be treated as public routes, and we can skip the auth validation. And for all the other requests, we'll extract the token from the authorization header, and based on that, all the validations required, and if the token is valid, then we are checking over here whether the key exists in the Redis. If the key doesn't exist, meaning the token is invalidated explicitly or when the user logged out. So the reason this is kind of a bit tricky and important, because let's say you logged in as a user and we have this 24 hours as a token validity. Now if you are not storing this anywhere, right, and if you logged out, so how exactly you want to persist this one, so that now if you request any secure routes with the same token which you already logged out, how are you going to verify? Yes, you can say that we can save the separate table in the Postgres stating that okay, the login activity where you can save all the tokens, you can do that. That is also fine. But for the simplicity's sake, I'm just using Redis with the same exact 24 hours expiry. If you want to know how exactly we implemented this and verified, you can go to the auth service video. And then once the token is valid and also token is present in the Redis, then I'm just attaching some meta information to the request object, user ID and token. This will be using actively in the actual routes. Error middleware is also same. I just covered in the auth service, but we'll try to catch any errors and send the respective HTTP response codes accordingly. And then we have this request middleware. This also I covered in the previous video. I'm just trying to print the request logger in the debug mode, the very first log. And then once the response is completed, I'm just trying to print the duration of the whole request, how long it took. Alright, let's start all the services and trigger each request, and I'll walk you through the data flow. I'm using Wave terminal just to make it a bit clearer. So we already are in API gateway, so we can just simply start the service npm start. Okay, so API gateway configured proxy, auth service, auth, account service to accounts endpoint, transaction service to transaction endpoint, and at the end if you see API gateway running on port 3000. Now let's start the auth service as well. Alright, so connected to Redis, Redis client is ready, Kafka producer connected, and at the end auth service is running. Alright, let's start the account service from the VS Code terminal, so it's a bit easy to stop and start if it's required. Alright, now let's start account service. Okay, so connected to Redis, Redis client is ready, Kafka producer connected, account service is running on port localhost 3002. Okay, now let's open Bruno and check first the health endpoint. So if you see here, account service base URL, the value is localhost 3002 already, and I just given /health. And this send arrow is basically hidden behind my cam view. And when you open Bruno, you would see a small arrow at the end. That's it. So just click, and you can see here service account service status okay. That's it. Okay. Now this health endpoint is working perfectly. Now let's look at the list. So what exactly is this list API? API v1 accounts. Let's just fire it out and see what is the response. First we got message unauthorized. Okay, now if you look at the pattern, auth, we are already having this token defined, but looks like this is not valid anymore, right? So first what we'll do, we'll just go to the auth and try to log in. Okay, so this is the email and password I just created in the previous video. Hope this is still working. So let's just shoot. Okay, we got this token, and this is also being set because in the post response script we are trying to set the token as an environment variable. So now let's run the account get list API. If you just call now, we got an empty array, meaning we don't have any accounts created for this specific user ID. Okay, so for that we'll just go through the create account. Okay, now currently we have this account type as current. This is the only payload we need, because rest of the information like for which user all can be pulled from this token itself, right? So now let's just trigger this API, which is post of API. And if you see here, we are accessing auth service via the API gateway only, right? So post this API gateway base URL /API/v1 and accounts. That's it. And the body we just send it as account type is current. And if you just hit enter, and now if you see account is created with ID as 1, user ID is 1. This is basically the actual user ID. Account number, account name, account type current, account status active, balance is 0, currency is INR, created and updated. That's it. Okay. Now let's look at the logs first, and then I'll walk you through the database view. If you open Wave terminal now, if you see here first, let's minify this. Okay, if you see here post API v1 accounts, we have this HTTP proxy middleware log as well. So post API v1 accounts, with the request came to the API gateway where it passed the request to localhost 3000 to /API v1 accounts. That's how we defined in the API gateway definition. If you're a new viewer, I would highly recommend to watch the API gateway video so that you will get clear understanding how these proxy routes are configured. And in previous, if you see, we call API auth login, then accounts, and for the failed request, if you see, we got this 401 as well, as per the status code over here, and here 201, 200. Okay. And in the auth service logs, you can see API v1 auth login status 200, 105 milliseconds. That's it. Okay. Now let's look at the account service logs also. And if you see here, we call this health, and then API v1 accounts, we got 401, then we logged in, then we call this get accounts, that is 200, 15 milliseconds, and then we call post API v1 accounts. And then later, if you notice, there is another important log message, publishing message to topic account.created with message so and so, message published successfully to topic account.created. That's it. And then at the end, we are calling 201, which all took 85 milliseconds. That's it. Okay. Now let's look at the definition, and we'll try to walk you through the whole data flow. So let's minify this terminal over here. Now let's start with the routes. Because in the app.ts, if you notice, we have this /API v1 accounts use account router. That's it. Okay. If I just open account router, so if you see here, I'm creating an account controller instance. Okay. And I'm binding the routes. So for the post /, because we already defined the endpoint slug in the app.ts stating /API v1 accounts use account router. Simple. So after that, if it is / at the root, that basically points to based on the HTTP verb again. So over here, if you see post, call this account controller create method. If it is get, call this account controller list method. If it is delete, call this delete method. And this is the route parameter. If you see, if you are Express.js developers, this is like a more familiar notation where we'll be extracting the account number from the route parameter. That's it. So we have 3 endpoints, like the actual business endpoints: creating account, get list of accounts for the specific user ID, and delete account. That's it. Okay. And then later another internal business endpoint, that is internal transaction. This I just created just to demonstrate credit and debit of balances in the accounts records. That's it. Okay. And for this also I have the another method, internal transaction method in the account controller. Okay. I hope till this part it's clear. And if this is helpful and you're learning something new, please make sure you hit that like button and subscribe, which will definitely motivate me to do more videos on these interesting topics. Alright, now let's start with the account controller definition, and internally we'll cover the account service as well, which actually holds the core business logic. Okay, now let's open account controller. This is basically residing in the controllers folder. Okay, account.controller. That's it. Now if you see the definition over here, we have this first and foremost create, which is binded to post request. So if you see here, we are getting account type and account name. Account name is also optional. Reason, if you see, we are using Zod for the validation. So for the create schema, I have only 2 fields: account type, whether it's a savings or current account, and by default we are using savings account. Also for the account name, same. If nothing is passed, I'm just using this constant savings account, that is basically savings account as a string. That's it. Okay. And after passing this request body to Zod schema, we'll get this account type and account name. And I'm just passing this as is to the account service. Along with it, if you see, rec.userid, how exactly this user ID is being resolved. If you remember from the auth middleware, once the token is valid and we are good to go for the secure routes, I am attaching the actual user ID, which we decoded from the JWT token, and pointing that to the user ID field in the request object, which can be easily accessed from the controller's request object over here. So that's how I'm just accessing rec.userid. So this is how we are basically pointing to create an account object, account record, for this specific user ID, whoever is actually calling this request. That's it. Okay, and then once the account is created, I'm just returning that as a JSON with 201 as HTTP status created code. That's it. Now let's look at the account service definition. This is again the similar class, which you can see the pattern exactly same as auth service, controller, and service definitions. Over here in the account service also we have this create method, and if you see, it is accepting an object with user ID as one field, account name if it's passed, okay, otherwise I'm just using the same fallback value, default value, and even for the account type, savings account. Because I'm creating an account create DTO over here where I define user ID as mandatory, account type and account name as optional. That's it. Okay, and in the create, if you see, I'm just using this account repository. This is also, we are defining this from the type ORM based account table. So these repository objects are responsible to connect to the database and do all the IOPS. So for this create method, first you're validating whether the account already exists for the same user ID and for the same account type. This dot account repository dot find one by user ID and account type. So if we find any record with this combination of user ID and account type, we really don't need to create another account, because for our example, I thought like at any point of time, one customer can have only one savings account. Yes, I know all the modern banking applications supports multiple saving accounts, but to make it a bit limited scope, let's stick to this business requirement. Like any customer can have only one account type, that is savings or current, not two saving accounts and two current accounts. Yes, we can create, but just to limit the scope, I think it's better. And now let's say if account already exists, we can just simply throw account already exists with 400 as bad request. That's it. And this create basically generates a proper error object, and in the error middleware, based on the status code, if it exists, that's how I'm just sending the status with the specific message. Simple. Okay, so in the account service, let's say if the account doesn't exist, then I'm first trying to create a type ORM based that specific table entity object. So in this case, that is account. Once the account object initiated, I'm just trying to set all the fields required. Okay, user ID, account number, account type, account name, and balance at the beginning, obviously it will be 0. Okay, and then if you see here, this for the account number, I just defined a util function, generate account number. Now let's look at the definition of generate account number. If you see, it returns 15-digit account number, okay, as string. Now how exactly I'm constructing? This is not like a rocket science. I just gave 5 minutes of thought process to define this specific structure for account numbers. Okay, let's start from the return statement. So first one is account type map of account type. So what is this? So account type map is nothing but for each account, I'm just having the prefix. That is like for savings, I'll start with 11, and for the current, I'll start with 13. Why exactly these numbers? I don't know. I usually prefer prime numbers, so 11 and 13. That's how I just define. Okay, so for the savings account, the prefix is 11, and for the current account, the prefix is 13. Simple. Okay, so overall for the 15-digit account number, first two characters indirectly represent which account type. That's it. Okay, that is over here. And then later we have this date field. Now let's just look at the Bruno's response. If you see here, the first two characters in the account number is 1 and 13, that is 13, technically represents current account type. Okay, and then if you see here, we have this 2025. So how exactly that is being defined? If you see here, new date, 2 ISO string, slice 0 to 4 characters. This basically gives the date year. Okay, and then I'm trying to generate 7 random unique ID characters, and for that I'm using nano ID package, which will try to generate the alphabets based on this specific notation. And the ID length actually 7. I just define it as an optional, falling back to the 7, just in case if we want to generate different lengths of the account numbers. For now we won't be using this ID length. So this unique ID will give us 7 random digits, and that unique ID is basically at the last chunk of the whole account number. Okay, so this account type map identifier will be placed at before as the prefix, and then date of the year, and then again after the year, and then the unique ID, just to make it a bit structural. Now let's verify this from the response. Over here, if you see, 13 is the account type, and then year 2025, and then again I got 13, and then the unique identifier 2383152. That's it. You might say that there is a chance of duplicates. Yes, there is a chance, but not like 100%. The reason, this nano ID will try to generate a unique identifier. Again, it based on the number of characters. Right now we just have 10 characters because we just need only digits, right? So there is a chance, but limited. We can test it out during the regression later in the videos. If we really see there is some issue, then we can tweak this to make it more unique. Let me know in the comments if you have any different ideas to generate the account number. We'll try to implement it. Simple. Alright, now let's go back to the account service file again, and if you see generate account number, I'm not passing the second argument, that is ID length, so it just fall back to 7, and this specific function basically returns 15 characters of only digits as an account number with a specific structure. That's it. That's why I'm storing this in account number field. And then later, this specific important line basically tries to create an account record. This dot account repository save and that entity object, in our case that is account. That's it. Okay. Once this is done, and if you notice, I'm calling one other function, that is publish account created. This is basically publishing an event to Kafka stating that an account is created. We'll just store it in a topic later if we need. Like usually for the account created, we can think of like, okay, notification service can subscribe to this topic account created and start sending emails or any SMS or something like that as a validation, anything. But we can just extend that. There are so many possibilities. Right now I'm just publishing a message to topic. That's it. Okay. Now let's just look at the publish account created definition. And if you see here, this exported publish account created is simple arrow function, and inside I'm calling account created producer dot publish, and the data what we just pass to this publish account created. So account created producer is again just a class extending a base producer with a generic type, and I define one read-only field as topic. And for this class account created producer, I'm using this user topics constant with the value as account underscore created, which will resolve to account dot created. So I had defined a constant as an object. If you see here, account created, account deleted, and user registered with that exact topic names. I'm just using this over here. That's it. So the pattern over here is, in the events we have this producers folder. So inside that, for each business event we'll be creating a different producer file just to make it more modular and easy to maintain. Just at this stage it looks kind of an over-engineered, but down the line it will be really helpful. So this for account created dot producer we have this one, and for account deleted also similar structure. Okay, if you see there's much of a difference, just the names over here are changing. That's it. Okay, and this base producer is basically the responsible for producing a message to that given topic. So this base producer, if you see this publish, what are the data I'm getting? I'm printing logger.info, publishing message to topic, this dot topic, and this dot topic again, as each producer class is being extended to base producer, topic is defined in the specific definition. That's it. Okay, and then I'm trying to send the message over here. So this is the important one. Producer.send, this producer is again basically coming from the Kafka.ts, this producer, and exporting this I'm using the same instance of this one. That's it. So inside the base producer, so I'm just passing topic and messages. And message also, see, for this data I'm trying to derive two values from the data object. One is key, which will be helpful for the partitioning, like for that message where it needs to end up in different partition based on the partition key that is over here. And usually we send key as a user ID. And for the value, I'm just stringifying that and saving as is into the Kafka topic. That's it. And then at the end, message published successfully. And if you see, this is debug because it's not really required as an info. And if there is any error, I'm just trying to log and throw. That's it. Okay. So this is how we are defining. For the consumers also, it will be under the similar pattern that we'll explore once we develop transaction service. Okay, so that's pretty much it for the create account flow. I hope this is clear, and I'll just open dviewer just to see on the Postgres side. And as you can see, we have this account table created, and if I just open this table in the data, if you see, we got one record: user ID, account name, account type as current, account status active, balance 0, currency INR, and other fields. So this is how it is being stored in the database. That's it. Okay. And now let's look at the Kafka also, how exactly the message is saved in the account.created topic. Now let's open Kafka UI for it. Let's just quickly refresh. Okay, now if you see here, account created, and in the number of messages you can see already one message is already there. Account deleted 0, that we'll try that also. So let's go to the account created, and if you look at the messages over here, you can see here. I'll just show you how this key is being resolved. This is basically the user ID. So if you see here, once the account is created, I am passing key and value. Key is nothing but, if you see here, user ID dot toString. This user ID is nothing but the request dot user ID that is being sent over here. Okay, so I'm just passing user ID as a key for the partitioning purpose, and the value is nothing but the entire account object. That's it. Now let's go back to the Kafka here and verify the details as well. So ID, user ID, account number, account name. So this is how the whole account object saved inside this account created topic. That's it. I believe till this point it's clear. Like for the account creation, how exactly we're constructing the account object, saving in the Postgres DB, and how we are sending that, and also how we are publishing a message to the Kafka topic, that is account.created. That's it. Now let's go back to the account list API. We'll first try to trigger that from the Bruno, and we'll see. So over here on the list, it's empty, right? Now let's just trigger this request. So get request API gateway accounts, And if you see here, we got an array of objects. At this stage, we have only one account and the account type is current account. Okay, so this endpoint definition is just a read operation. I'll just go through the implementation. So if you just open account controller, this is the list. Okay, if you see in the routes, account route, for the get slash, we are using list method. That's it. So if I just open list method, this dot account service list, I'm just passing rec.user ID. Again, this user ID set in the auth middleware. And now let's look at the definition of list in the account service. This is nothing but a simple find request where user ID equals to the given user ID, which result from the JWT payload. Simple. Okay, and then we get the response as an array, and I'm just returning that as is. Account.controller, this accounts, res.status 200, JSON accounts. That's it. Okay, now let's create a savings account and just verify it. For that, let's open Bruno again. For the create, instead of account type current, let's just send savings. Okay, send. Now the response came, ID is 2, account number is different, account name is savings account, account type is savings, and the balance is 0. Okay, and the status code is 201 created. Now let's jump back to the list API and just trigger one more time. Now we should get 2 accounts for this user ID. Now we got 2 accounts for this user ID 1. Okay, now there is one small issue over here. If you see here, for the current account, as I didn't pass any account name, it just saved the default value of savings account. Ignore this one, but we can just send the account name also just to close the loop. Also, we can just delete this. Now that we covered the create and list accounts, now let's cover the delete account as well, so that we can just delete this and create again with a proper account name. Okay, and now let's go to the delete account. Maybe I'll just walk you through the definition of it first. So let's open account.route again. So for the delete, we are passing route parameter as account number. So now let's look at the definition of this controller method, and looking at the definition, we are just calling the delete method of the account service by passing 2 parameters. First is rec.userid, which again coming from the JWT payload, and the other one important, rec.params.account number. So this account number is being resolved from this route parameter. Okay, so this is how I'm passing it over here. And now let's look at the definition of delete in the account service. This is simple again. First, I'm trying to get whether the account exists in the first place by passing user ID and account number with this query. Account repository find one by user ID and account number combination. If I don't find anything, then there's no point in deleting. So I'm just going to return 404 with account not found. Simple. Okay, I need to delete it, right? So I'm just use the same query, user ID and account number, delete response. So once I get the response, I'm again checking whether affected count should be 1, right? So if it is 0, basically by this, during this operation, maybe account got deleted with some other request, right? So I can just call again account not found 404. Else if affected count is 1 and technical account was there and it got deleted with this operation, and I'm just logging it, account number deleted for user ID. Looks like event is missed over here. And then later I'm publishing a message to account deleted topic, and just looking at the definition, publish account deleted, this is again the Kafka procedure, and the topic, if you see, user topics account underscore deleted, and the values account.deleted. That's pretty much it. And in the else case, I'm just printing an error message and I'm just throwing an error with account deletion field as 500 status code. That's it. Okay, now let's test this behavior once. Now let's open Bruno, and if I just send this one, this is an old account number, so even if I send now, it will fail. Yeah, and message is account not 4, status code is 404. Simple. Okay, now let's go back to the list API, just trigger one more time. We got this one. So for the current account, let's copy this account number and just add it over here. That's it. Okay, now let's just trigger the request. If you see here, account deleted, that's it, and the status code is 200. Now let's go back to the list API and just send one more time, just to make sure that we are getting only one account object. That's it. Okay, now let's go back to the create API, create current account with a proper account name. That could be, let's say, v current account, and the account type should be, of course, current account. Okay, let's hit enter. Okay, now if you see here, account name v current account, now it makes sense, right? Okay, now let's just go back to the list API and just send again, and if you can see here, we got 2 accounts over here. That's pretty much it. So overall, till this point, we covered 3 endpoints: creating an account, getting a list of accounts, and delete account. Okay, now let's go to the internal transaction, which is again just to close the loop and to make sure that okay, this is working. Let's say if a customer deposited cash from the ATM, which is kind of a credit transfer, and let's say if someone withdraw the cash, which is kind of a debit transfer. Again, we can define the account transaction type as separately, but just for simplicity's sake, till this video I just went with credit and debit. Now let's look at the definition of this internal transaction, then I'll try to walk you through the execution. Now moving back to the account route again, and for the endpoint / internal transaction, I have an internal transaction method in the account controller. So let's just open this one. And with the Auth schema again, I'm trying to resolve account number, amount and type. And the definition, if you see, transaction schema, account number z string length 15, amount again in decimals with a multiple of 0.01, which resolves to 2 decimal places validation, and type, which basically a transaction type. I defined it as credit or debit. Now moving back to the internal transaction definition, we are resolving account number, amount and type, and then just passing these values as is to the update balance of the account service. So this update balance method, if you see, it is accepting user ID, account number, type and amount. That's it. Okay, now let's look at the definition of update balance in account service. This is kind of simple for now. First, I'm trying to fetch the account with this account number and user ID. If it doesn't exist, then there's no point in doing any transaction, right? So that's the validation over here. And then later, if account exists and if it is credit, I'm just passing plus amount, and if it is debit, first I'm validating if there is sufficient balance. If that is not the case, again throw the error with 400 bad request, and if it is valid, I'm just subtracting. That's it. And then at line 127, I'm just trying to making sure that the decimal places are 2 and setting to account.balance. That's it. And over here, this .account repository.save, which will basically update in the account record. That's it. Okay, that's pretty much it. Now let's trigger the request over here. So again, I need to copy the account number properly. So let's go back to the list API. Let's trigger one more time. Now let's add 1000 to the savings account. Okay, so in order to do that, let's copy the account number over here, go to the internal transaction, paste it. Not even 1000, maybe 1001, just to test this out. Okay, type credit. Now if I just send account transaction credit completed, available balance 1000.01. Now let's just send again just to test it out, 2000.02. Now let's just change this to debit. Okay, and then maybe just do 10.01 just to test it out different possibilities. Okay, now I'm trying to debit 10.01 from 2000.02. Okay, just send account transaction debit completed 1990.01. Maybe let's just do debit. I kind of like the edge case testing, so 0.01, and now if you can guess, the number should be 1990. That's it. Account transaction debit completed. Now let's trigger the insufficient balance also, maybe like 10,000 over here, and debit. Okay, we got this insufficient balance. That's it. Now let's go back to the list and just trigger so that the balance should reflect. Okay, for the savings account, if you see, the balance is 1990. If you just want to re-verify, this is the account number 66781. Now let's look at the internal transaction 66781. That's pretty much it for the account service. So total overall we have 4 endpoints, out of which 3 are actually business core APIs, creating an account, listing accounts based on the user ID, and deleting. That's it. Okay, and we have an internal transaction just to verify the transaction methods. That's it. Alright, I believe till this part it's clear, and I covered almost all the changes required to complete the account service. Now I just want to cover the architecture overview at this stage and what we are changing in the next video. So if you look at the current architecture at this stage, any request coming from the client goes to the API gateway, and API gateway passes it down to the respective service based on the endpoints according to the proxy configuration. So at this stage, Auth service is generating the token, and for any secure routes within the Auth service can validate the JWT token. And now for the account service or for any microservice that we introduce in this course, need to validate the JWT token which is generated by Auth service. So all the services will have a reference to the same JWT secret so that each service can basically validate, and on top of it, each service will verify whether the token is present in the Redis or not. And if the token is not present in the Redis, that meaning either the token is explicitly invalidated, and one example is basically if someone logs out, and if anyone logs out with a valid token, Auth service will remove the key from the Redis, and from that point the generated token, though in the expiration context it is valid, as the token is not present in the Redis, these services will not accept the token and return 401 unauthorized. That's it. Okay. At this stage, all the microservices are responsible to validate the JWT token along with an extra check whether the token is actually present in the Redis or not. So this layer of JWT validation across all the services can actually move to API gateway. So API gateway, whenever it receives any request, it will have a set of public routes. Apart from that, if any secure request comes to any of these services, first API gateway will validate the token. So this API gateway also will have the same JWT secret key which will validate the token and also make sure the token is still valid and present in the Redis. And if I just scroll down, so this is how it is. So in the next video, we'll be covering how the API gateway basically validates the JWT token and also the existence of the token in the Redis. If it is not there, so instead of passing the request directly to that specific services, API gateway can just simply return the response as 401 from API gateway layer itself. It doesn't really need to send the request to that respective services. So that is one way of auth validation at the API gateway in microservices. Along with this, API gateway can also set some extra request headers so that underlying microservices can look for those request headers which are set by API gateway in order to validate or extend the validation. It will be more clearer when we cover in the next video, but that's the overall gist of it. And in this video, I actually didn't walk you through the Redis UI because that I already covered in the auth service video. And for the new viewers, I would highly recommend to watch this from the beginning of this series, which will make more sense overall and help you understand from scratch. And now if you look at the folder structure, slowly it's kind of getting a bit messier, right? So we'll be creating a separate service folder and we'll move all the service definitions into that services folder. And also if you see, there is a pattern going on. In the auth service, we have this config folder, more or less same, and the same is applied in the API gateway config, logger and Redis, and also in the account service. So for this, we'll improve by creating an internal npm packages so that those npm packages will be stored in a separate packages folder along with the services folder, and we'll try to generate the packages locally and use those as an internal packages across all the microservices. That will be exactly a real-time use case. So currently we just developed just to close all the loop. So from this point, we'll make it more modular and organized by having a common packages, and will we use that across all the microservices as an internal Node.js packages. And extending to that, not only just the config, and if you see here, the middlewares, we have this rate limiter over here, but if you compare the account service middlewares over here, auth, error handler and request middleware, more or less the code will be same for the account service and also for the auth service over here, and for all the other microservices down the line, let's say the transaction service and notification service, more or less basically abstracting these middlewares also as a common packages. So that will be a very good learning. So stay tuned for the next video. And also I would like to bring some points. One is about code sharing. So right now I'm giving 1 week of buffer for each video, and most probably and in the next following week, either Wednesday or Thursday, I'll basically make the branch public so that you compare that with along with your changes. So you have this 5 or 6 days for you to work on this specific video and explore your own way of doing this stuff and try to compare that after I make the branch public. So that's about the code changes, how I'm going to maintain and publish in a timely fashion. And I also have a Discord channel, so make sure you join the channel so that we can discuss more about this project and also any other projects down the line, and also making it as a proper community for more active discussions. And also if you found this series helpful, make sure you hit that like button and subscribe, which really motivates me to continue this course. And also please share this content within your network to make it more reachable for a wider audience, and let me know in the comments if you have any doubts. That's all for this video. Thank you so much for watching, and I'll see you in the next one.